South African Institute of Physics webinar. I am Rudolf Erasmus from Wits University, and I'm the council member that will be hosting today's webinar. The proceedings will be recorded, and the recording of the webinar will be made available on the SAIP Facebook page shortly after the conclusion of the presentations. The purpose of this series of webinars is to communicate on a wide range of topics to the wider physics community, and today's topic is that of the South African Physics Olympiad, being presented by Mr. Kasa Reisdijk. He was educated at the Kabulonga Boys High School in Lusaka in Zambia, and he graduated from UCT, where he studied astronomy under Professor R.H. Stoy at the then Royal Observatory in Cape Town. He taught physics at St. George's College, Harare, and Bishops in Cape Town before returning to the South African Astronomical Observatory, the SAAO. He took early retirement from the SAAO in 2003 to continue his interest in particle physics and writing, but he is still involved with teacher education, the SA Physics Olympiad, and numerous outreach activities. In addition, he serves on several science advisory councils, has twice been president of the Astronomical Society of South Africa, and delivered the Bernard Price Lecture for the SA Institute of Electrical Engineers in 2003. In 2009, he was awarded an NSTF Special Award for his contributions to physics, astronomy, education, and science communication over a lifetime. He's also an honorary member of the Astronomical Society of Southern Africa, the Royal Society of South Africa, and the South African Institute of Physics. In 2017, he was awarded the prestigious Gill Medal of the Astronomical Society of South Africa for his contributions to astronomy. So we are very pleased to have him as our speaker, and the title of the webinar is the South African Physics Olympiad. Over to you, Kasa. Case, we're looking forward to the presentation. After the presentation, I will facilitate the question and answer session. Thank you.
Many thanks, Rudolf, and welcome to everybody. The Physics Olympiad is a 90-minute, 50 multiple choice question assessment seeking to identify scholars with ability in physics. And South Africa, like every other country around the world, has an enormous number of talent that we don't know about and we find difficult to identify, and we need to do this. Unfortunately, South African schooling system currently, I don't think we'll be able to do this, primarily because we teach physical science, which is physics and chemistry together. There has been moves to separate the two, but it hasn't happened yet. And unfortunately, it gives a bit of a handicap, which we'll come back to later on. Now, SASA runs a very nice and very good science Olympiad that attracts around about 20,000 scholars a year from all over South Africa. And the SAIP and SASA, we've got an arrangement, a collaborative arrangement, so that we can use their Olympiad, the National Youth Science Olympiad, their finalists as our first round for the Physics Olympiad. We can then invite candidates to enter the Physics Olympiad. And because the SASTA Olympiad is a truly national Olympiad, means that the participants that we select are also from all over South Africa, including, very importantly, the rural areas. Now, SAFA is usually written on the first Monday of National Science Week in early August. The paper we normally tend to set around about April, May each year, and we then send it to the Spencer Wheaton at the University of Cape Town Physics Department, who moderate it and make comments and improvements if necessary. And then once that paper is done and settled, then we just wait for the results from the National Youth Science Olympiad. They write in March, April, and the results become available around about June. And they are sent to us at the SAIP, and we then select the candidates, we contact the schools, and send out the invitation. Those schools that are willing to participate are then sent instructions and other details. It's for many schools, this is a new experience, and they require quite a lot of assistance there. Once that's all settled and sorted out, then they have been informed that they will be sent a question paper, a data sheet, and an invigilator form on the day of the exam. They're normally sent out in the morning. The exam starts at about any time between 2 and 3:30. There's a 3-hour slot from 1400 hours to 1700 hours. And the reason for that is it gives, many schools are available sometime in the afternoon, but I don't want to fix the time slot. So they've got a 3-hour window in which to put their 90 minutes. And they can do it any time to do that. But of course, if they've logged in to do it, as we do most recently, they get logged out after 90 minutes or 1700 hours, whichever comes first. So when the SAFO is finished, the invigilator's form is completed, scanned, and then emailed to the Institute of Physics. And we have to keep these records, and they're very, very important. In the past, the answer sheets, we used to mark them on a grid, as you do with multiple choice questions, and they were also scanned and sent. Now, the invigilator's form is there because we need the details of the school, the name of the school, the students who took part, their name, and in addition, we ask them to answer the following questions. Because we need to know sort of whether we're missing people or whatever it is. And I'll give you the results of this feedback later on. The invigilator is also asked to fill in the following as well. And that is, would they participate again, yes or no? And would you encourage more learners to enter, yes or no? And then the other item is really, really important is the school stamp, believe it or not. And the reason for that is that our funding comes from various sources, DSI and SASTA and various others, and they need evidence of participation to make sure that our funding is being used correctly and so on. In this day and age, that's quite an important feature in South Africa. So, but we'll see the feedback to these results later on. Now the question is, why do we need the Physics Olympiad? Well, in 2005, we had the report, the sort of Shaping the Future of Physics in South Africa. And in recommendation 4.1.4 on page 49, they suggested that the panel recommends that the physics community led by the Institute of Physics should seriously take up the challenge of preparing South African school children for participation in the IPHO. Now, I was always been a great supporter of the International Physics Olympiad, and I was privileged in 2003 to go to Bali as an observer to see how all this, the International Physics Olympiad worked. And I realized there that it was some way off for South Africa, and we'll discuss this later on. But we are just not really able at this stage to enter competitively. And I feel that the Physics Olympiad in South Africa is a more suitable interim goal to fulfill the needs to fill the physics pipeline. And here we have a quick sketch of the pipeline from schools to tertiary education and all the various branches that can happen, but it has to start there with scholars. People at school need to be selected and identified. So otherwise we can't really do this thing properly. In order to find scholars with talent for physics, you have to assess an enormous number of people to have an ability in physics. And the only realistic way to do this is to use a multiple choice assessment. And this can be used for initial or a second round, but such an assessment has challenges. The main one we all know about, was the answer worked out or did they take a guess? I mean, I've seen kids rolling pencils, which have got little marks on them for A, B, C, D, E, and no sort of thing. So, you know, that is not uncommon. So ultimately, you'd like to reduce the frequency of guessing answers for multiple choice question assessments. And there are possible ways of doing this. And one of the ways I think is to use what we call mark allocation. There are various potential methods to reduce the amount of guessing using a different marking system. And so I'll just quickly review what we have done and what we are hoping to do. So traditionally, you mark a question, 1 mark for correct answer, 0 for an incorrect answer, which is fine, but of course, you never know whether it was guessed or not. One way to address this was tried, and that was to give 2 marks for a correct answer and then deduct 1 for an incorrect answer. But that I don't really like that, because this negative marking is not very good, and it is possible for some poor child to get a minus score, which is, not really what you want. But there's one that I've tried now. This one here, this is 4 marks for a correct answer. 1 mark if you don't know you don't understand the question or you can't answer it. Just don't fill in anything, just leave it, and you get 1 mark. But if you get it wrong, you get no marks. And then you can escalate this basic structure to 4, 1, 0, plus 1. Now, every Olympiad paper has a number of very difficult questions. And if they get that, you can give them a bonus mark. And it's hard to do this, but we'll address this problem later on. But that's another scheme that can work. And then we've got this one too, where you can go 4, 3, 2, 1, 0, or 1 for the bonus. And this is for partly correct answers. And we'll have a look at that situation later on. But quite often, a person answering the Olympiad makes one mistake in changing the subject of a formula, changing a negative sign somewhere, forgetting to change units from kilometers per hour to meters per second or something, but they've got everything else right. So basically, the physics isn't too bad. They made a mathematical error. So they deserve some credit for that. So, I mean, normally if you mark a normal question in an exam, you get marks as you go along. With multiple choice, it's all or nothing sort of approach. So this, I think, is a possibility that might help that situation. So multiple awards, you can vary the number of marks for each particular question. Now, for example, there may well be questions that are conceptual only. So they can only be right or wrong. Or you can say, well, I don't understand the question, or I don't know, in which case 410 would work. But in a situation where there's a calculation required, then it's possible, and we go through this approach just now, it's possible that they've got the answer that they've selected is a possible answer where they've made 1 or 2 minor mistakes. So we can do that, have a look at that later on. And the bonus mark is really proved very, very useful when it's being used for breaking ties. Quite often tie scores are equal, and these will break the ties. Now, the traditional method of marking was with an answer sheet using a marking grid and scoring 1 or 0. Processing results was tedious, very time consuming, open to errors, and it was impossible to do any real analysis to find out whether a question was good or bad, or whether detractors worked or not. So in June of 2017, we had a trial run of a hybrid Olympiad. It was held for 10 schools that were approached, and they agreed, they volunteered. And here the paper was sent to the schools as usual, but they had to register online beforehand, and they answered the paper online. This, of course, meant that the data was digitalized, so you could do a detailed analysis of that whole process. And this proved to be quite successful. And it showed the benefit of giving credit for not guessing. So we'll have a look at this just now, but you can also identify how many people answered each question, how the detractors worked, were they good or bad, was the question good or bad? So you can do quite a lot. So here, the hybrid approach meant that schools without technological capacity could do SAIP online without having to download the paper. They could just simply answer the paper that we send them, and they can then do it online in reverse. And in that 2017, there was this girls' school outside Pietermaritzburg in one of the townships. And they had incredible initiative. They didn't have computers, but they had cell phones, and they used cell phones, turned one of them to a hotspot, and they logged in with other phones, and they answered the Olympiad. It was incredible. And it went to show that this is a possibility for the future. The online trial was held with 10 schools, as I said, and it consisted of 10 questions with 4 or 5 alternatives, and the marking scheme was 410. Interesting to note, now, and this one here, it's interesting to note how many ones there were. If you look around here, you see there's a lot of ones. And that means that they didn't guess. They just didn't know what the answer to the question was, so they left it. And so, for example, the first question on light was very, very easy. Everybody answered it correctly. The question on electricity, it was actually a very, very tough question. And you can see that most of them just took the 1 mark. This was a more standard question, some right, some wrong, and some again ones. And you go through it and you find you can already, with this very simple approach, discover that I think that the system of scoring 1 mark for not guessing is actually a positive result. The aim is to give candidates credit for doing partially correct answers as well. And the June trial, I think, was very, very encouraging in this aspect. It would give a better assessment of their physics knowledge, identify their ability to solve problems, identify good or bad questions, develop better questions and detractors. I mean, with multiple choice papers, it's easy to set the question, give the right answer, and just randomly select some detractors. But the detractors should actually be worked out beforehand and become real detractors, not just another answer. And this approach, of course, means that setting questions becomes much more difficult and needs a completely revised mark allocation. So 2018, the Physics Olympiad was a hybrid online Olympiad, but results were collected, digitized, and analyzed. Because it was not a totally online thing, the scoring was restricted to 410. It's very difficult if you're still using the answer sheets with those things and to give questions very complex structure, because some of the people answered with the traditional answer sheet marking, and you have to mark it through a grid. But it did work. And the serendipitous spin-off was that it showed that SAFA could be online, but give school lacking computers the opportunity to still participate. So this was quite a sort of a breakthrough in a way. But we're getting closer, and hopefully 2021, that's this year, that we will get there. Now, some details from 2018. This is the participation by gender. And we can see it's a huge imbalance between male and female, which is another thing we've got to address, but that's another issue. Participation by grade. Normally, it's the Olympiad is aimed at grade 12s, but sometimes there are grade 7s, grade 11s that enter, and sometimes there's a couple of grade 10s. Results show that the people in grades 11 and 10 don't often do very well. And then participation per province. I've got here 5. There are others, but they had too few candidates to make the pie chart. But it goes to show that where the distribution is. Results, the data is, it shows kind of a strange sort of distribution, but because the candidates have been selected because they were supposed to be sort of better than average, you're going to get a slightly skewed distribution, but it's pretty fair. The top marks in the Olympiad are normally sort of in the high 70s, early 80s. We have had 1 or 2 occasions where there have been scores of over 90%, which is quite phenomenal because it's not an easy exam. And gender results, you can do this analysis too. And also by grades. So you can see the grade 10s and the grade 11s here in this particular year did a little bit better than the grade 12s. But that was, I think, because we allowed 1 or 2 schools to enter without having gone through the other Olympiad, the SAIP Olympiad. Occasionally we get requests from schools, can they participate, please, but they didn't do the other Olympiad. And I say they can enter their top few students, but they should actually do another Olympiad to give us some ideas to the capabilities. And of course, you can extend, once you've got the data, you can actually extend it to province and per school and actually individual and everything else. Now below is a small extract from the XLS spreadsheet for 103 candidates answering 50 schools, multiple 50 questions. And you can see it becomes quite a massive thing of data, but of course, with computers and XLS, you can actually resolve a lot. But again, it's very interesting here to see the number of ones, which I think is very positive. The typical results for a question, you can do the analysis now. Here's a question on light, which was in fact an easy question. And you see 48 got it correct. And the detractors were fairly regular. And no, 8 people didn't answer the question. So they got a mark each. And here, this was a slightly more difficult question. But again, it shows clearly that 5 was obviously a poor detractor. Not many people chose it. And 11 people didn't answer the question, so they got a mark. But it's the analysis can now be done. So you can go back, look at that question, and take out detractor B. And again, here's a different one, but same sort of analysis. These last 3 questions here, the oil drop, the wire cube, and the Hadron Collider, were very, very difficult questions. And you can see that of the students, 72, 59, and 62 didn't answer. They couldn't answer it. And you can see here that the detractors were fairly uniform. So they were reasonable, whereas in the floating here, the detractor, 77 got the wrong answer. 41 chose that one. That was obviously an obvious detractor. And these were, well, you know, one could probably make a slight adjustment. But the analysis gives you a huge amount of data that you can use to improve the questions, improve the detractors, and improve the assessment. The other advantage of doing this online is that the candidates have to register. The details can be added to our database, and they can be followed up and monitored later on. And the answer data can be digitally analyzed for far greater depth, and so assist in evaluation of both candidates' ability and the question quality. And has the potential for multi-mark answers to go some way towards eliminating guessing and so get a better assessment, as I've said before. It gives a fair, I think, a fairer assessment of the candidate's abilities. But setting questions has become far more challenging for an online multiple choice exam. If you're going to do the multiple mark questions, in other words, giving credit for partially correct answers, it's going to be much more time consuming to set the question. You could actually work out, do the question, work it out, and make a mistake deliberately to get a particular specific answer. You can then use that answer as a detractor. So you've got to go through quite a complex process to prepare the detractors properly. You've got to look, as you're solving the problem, find out where you can make a deliberate mistake, like transforming the equation or resettling the equation, and you make a mistake. And see what answer you get. Maybe you'll be able to use that as a detractor. It becomes possible to evaluate the ability and solve the problem, and even with the wrong answer. So even if the child gets the wrong answer, he can still get credit if he gets most of it right, which is normally in an exam when you do write out a question in an exam and you go through the answer, you make a mistake, but you still get marks for getting, for example, selecting the right answer, the right equation. You get a tick. Doing something else, you get a tick. And in multiple choice, that's not possible, but you can do it if you use the multiple mark scheme. And you have to think out the problems very carefully so that that some knowledge of the student's problem-solving approach can be evaluated. It's easy to dream up hard questions or easy questions, but you've got to try and identify questions that will actually not guide the student, but sort of let them know that if they do this, they're going to go in the right sort of direction. It becomes quite a problem to select these problems, but it is possible. And then, as I said before, there are about 7 questions in each exam that are really hard. I mean, they are very, very hard. And some first-year students and second-year physics students can't answer them either. So it's quite good. So here's an easy example. A girl on a bicycle starts and rests, reaches a speed of 36 kilometers per hour and a distance of 36 meters. what's a girl's acceleration? Fairly straightforward, common type of question, not very difficult. And they are the answers that are possible. And if you use that equation, you get that answer, which is correct. And obviously, these answers are incorrect. But this one here, 18 meters per second squared, is a ridiculous answer. I mean, it's like a military rocket. But if you look at it very carefully, what the student did, or what the scholar did here, was they forgot to change 36 kilometers per hour to 10 meters per second. So they got everything right, except they chose the wrong thing. So they get this answer. So if you use a mark scheme like this, they get some credit for getting most of the question right. They used the right equation. They did the right transformation of the equation, changed the subject of the formula correctly, but they forgot that simple matter. So I think it's a good way, and it's a good illustrative example. Here's a more difficult question. An object of mass m is projected downwards with velocity vi. Then reaches a velocity, final velocity after t seconds at a height h above the Earth's surface. The kinetic energy of the body at this point can be expressed as, and I'm not going to go through the problem because it's quite not a bit difficult, but it's a bit time consuming. But here are some answers. Now, obviously, this is the act, well, not obvious, but this is the correct answer is D. Obviously, the height has got nothing to do with it above the Earth's surface. So the first two answers here are obviously incorrect. But these two other answers they look very similar to this one. And if you look at it very carefully, you'll find that this one here, they've forgotten to put a 2 there in front of the, in front of the V, there should be a 2. And here they've left off the square from the G. So these would, to my mind, get most of the question right, but they didn't get quite the right answer. And it's a nasty bit of mathematics anyway. But the point is that you can't give the bonus mark for getting it right. And it's one way to get a much better evaluation. Yeah, and I really think this is actually a very nasty question, but anyway, there it is. And then the feedback survey, we asked the invigilators to comment on the paper and whether they would take part in future. And I think these results show quite clearly that I think we're doing okay. Now, the whole issue of the International Physics Olympiad and the South African Physics Olympiad is a difficult one. But the International Physics Olympiad is written in July every year in the Northern Hemisphere. And all pretendants must be participating at school. So we can't take, for example, students that have done their matric or writing at university, they cannot write this exam. So the South African scholars in July each year have not finished their syllabus here yet, their curriculum. And so they're at least 6 months behind the Northern Hemisphere colleagues. And then take into account that the CAPS curriculum is probably 18 months behind the English A-level exams. In other words, they're nearly 2 years behind their competitors in the Northern Hemisphere. And it is essential that if we're going to take part in these sort of exams, that we must be able to compete at some level. And right now, we're not really there. And the additional mathematics is also required, as IPHO requires a very high level standard of mathematics as well. So what's the answer? Well, here's a possible solution. In most other countries in the Northern Hemisphere, scholars are selected or identified early on and selected to attend training camps for quite some time. And they go to a number of these before they enter the International Physics Olympiad. The top 10 South African Olympiad scholars could all attend an offering, a school, go to a school where they offer a post-matric year, and they can do A-levels. They could attend additional physics classes and maths classes and get training for an extra 6 months. This would better prepare them for the International Physics Olympiad. But whilst this might be a solution, it's an enormously expensive answer. So the budget for doing this sort of thing via a post-matric year at a school in South Africa would come to about 5,000 Rand per person, or for the team of 5 to go over to Physics Olympiad, about R1 million or budget would be required, which seems to be an enormous amount of money for a select few people. So it would be better, I think, to award the top 10 Physics Olympiad scholars a scholarship from 20 to 5,000 Rand or whatever it is. It would encourage them to take part. We've identified the talent, give them a boost to do well. And I think most South African students that actually are capable, that enter university, having done well in something like the Physics Olympiad, will pass the degree in the normal prescribed time and go on to do postgraduate work. So I think that the Olympiad in South Africa is currently probably an answer before we have to start spending huge amounts of money to get to the IPHO. The future, unfortunately, in 2019, we couldn't have the Olympiad because there was a problem with the National Youth Science Olympiad and we couldn't get the results in time. So we could not run a Physics Olympiad, which is very sad, but that was the way it was. But we did do a climate and physics quiz, which was held as a precursor to a fully online Physics Olympiad in 2020. And that worked. And I think that should be 2020 that we couldn't do that. But COVID-19 put paid to the 2021 planning. So we, at least the 2020 Olympiad. So we now are planning for 2021, and that planning is in progress, but we have 1 or 2 glitches. Hopefully we can sort them out. So I believe that SAFO is on the right track and we could look to the future with confidence. Thank you very much for your time. And I must acknowledge and thank you to these people who've been, Spencer, at least very, very important in getting the thing going. So thank you very much indeed, and I'm happy to answer questions.
Thank you very much for that presentation, Kees. There are 1 or 2 questions already popped up. Aswandini asked, he said, in your choices for multiple choice questions, what does don't know mean?
Sorry?
The question was in your options for multiple choice questions. One of the options was don't know. And the question is, what do you mean by don't know?
Well, in other words, if in the marking grid, they've got A, B, C, D, E, and they've got to cross out either A, B, C, or D. So if they don't know, they just don't answer the question, leave it blank. And then they get a mark for that.
I see.
In other words, when you're marking that grid of answers, if there's no cross in that whole line, they get a mark because they didn't guess an answer.
I see. Okay, so that's sort of an...
Do you understand that?
I understand. The blank answer is don't know.
Well, if they don't answer it, then we say, well, he didn't answer the question. At least he didn't guess an answer.
I understand. Yes. Okay, there's a question.
Asgundini's hand is up. Sorry. I think he needs to follow up on the question. Asgundini's hand is up.
Okay, thank you very much. I did not see that in the participant list. Maybe what I'll do is ask Aswandini to respond.
Yes, thank you.
There we go.
So if I calculated the correct answer, and for some reason I thought I was choosing C and I chose E, but I calculated the correct answer. Therefore, it will either be 0 or who didn't answer gets a +1.
Yeah. Look, you can't cover every possibility. If a person makes a mistake by crossing out, he or she has worked out the correct answer, but then marks the wrong box. There's nothing I can do about that. It's, that's one of the disadvantages of multiple choice questions. I mean, that's it. I can't, there's no verbal contact. There's no correction or anything else. I mean, that's the way it is. I can't help that.
Thank you. There's a question from Derek Fish. I'll get to Rudzani just now. That was posted in the question and answer. The question is, in analyzing the questions, are you familiar with the discrimination index for multiple choice questions? The comment is that it is then very easy to calculate and gives insight on the ability of a question to discriminate between top and bottom students.
Yes, I'm aware of it, but I haven't had a real opportunity to use that yet. We're hoping to get into that in the future.
Okay, thank you. Rudzani, please go ahead with your question.
No, I just wanted to very quickly make a follow-up comment on Azundini's question, which has already been closed, I think. But I was just wondering what will happen to a student who works out the answer, gets the answer, they feel they got the answer, but there is no option of none of the above. So don't you think that forces them to just say, I don't know?
No, I think it's been experienced that in multiple choice questioning and answering, none of the above is not a good detractor. So it's not used. And I personally don't think it's an option. It's better for them to realize if they don't know, then if they can't see any of the answers that they want there, then either they've made a mistake or they must say, well, I'm not going to answer the question. Because I mean, if they've done the problem decently and you've set the question properly, then even if they've made a mistake somewhere, one of the detractors will have that incorrect answer. And that's the object of setting more difficult, when you're setting these multiple mark answers. That's why you go through the question beforehand, work out where the mistakes can occur, put those answers into it. So if a student has worked through the paper and he believes he got the right answer, but he can't find it, then the chances are he hasn't worked it out correctly. So I don't think none of the above is actually a viable option.
Rudzani, is that answer your question?
No, I'm answered. I mean, we can discuss about whether none of the above is viable or not. But I think that I'm clarified.
But I mean, the point about it is that if you say none of the above, what is the advantage of saying none of the above? Because he's got the wrong answer. So it can't be right.
So I accept that in setting your question, you don't like probing the knowledge of the students by giving them answers that are all wrong and see if they will figure out confidently that there is no right answer here in this list. I accept that.
If you're going to set a question, it must have a right answer. That's why we have a moderator. So the question is correct. The question has an answer. And if he doesn't get that answer,
okay.
That's it.
Yeah, now I understand.
Aswandini, you had a follow-up hand?
Yes, it's a different topic now. Will it be simple to conduct this online during times of COVID-19, given that at higher institutions of higher learning, there is much cheating when students are studying online?
Yes, there's very little we can do about that. But having gone through this quite carefully myself, you've got 50 questions and 90 minutes to do it in. So you've got less than, well, you really don't have too much time. So even if you've got a question and you're going to try and cheat by getting the answer from the internet or from a book, you really haven't got time to do it. It makes it, you just try and do it sometime. Look at some of the questions, even in a matric paper, and try and just do it by looking in a book or searching the internet. It's not easy. I've also found out that there is a possible way of cheating if a teacher helps, and if the teacher is competent and can answer the questions, that of course is a possibility, but one has to, at some stage, have a little bit of faith in the supervising staff, otherwise we're lost. I think basically I've not experienced a real problem with that.
Okay, thank you. Are there any other questions at this stage?
Yes, from myself, Rudolph,
Yes,
it's
right.
the participation of girls, yeah, which is a given. But in the history of SAPO, do you have any girls coming up in the top 3? Because I joined after you had already started, so I haven't seen any girls. So previously, have you had any female winners?
Yes, there have been female winners, but not since I started the Physics Olympiad. Yeah, the very first Physics Olympiad, the winner, there was a tie for first place between a girl and a boy. A girl, can't remember her name now, but she was a white girl, the black guy came first with her. He went on to do a master's at UCT, went to States, got a PhD, is back teaching applied maths at UCT, and the girl she did electromechanical engineering. She set up a very sophisticated electromechanical engineering company in Cape Town. So yes, we have had girls, but I think it's a problem we have, and we are trying to address it with WIPISA and various other organizations. But those are the facts, and I have nothing I can do about that.
Thank you. Derek Fish has his hand up. There we go. If you unmute, there we go. Please go ahead, Derek.
Thank you. Kees, can you hear me?
Yeah.
Okay. Thanks for a great presentation. Kees, you and I have had discussions before about various other multiple choice quizzes which don't always pay careful attention to distractors and that sort of thing. And I'm just thinking it might be useful through the Physics Olympiad to actually develop some guidelines, as to what makes good and bad questions, use of discrimination indices and so on, what sort of marking should be used. Because, you know what we're talking about, but they're quizzes where you'll have a true false followed by a 4-part question, followed by one with no, and it really doesn't mark well, and it doesn't give you an indication of who actually the best person is. So I'm just saying, I see on your thanks, you've also got John Webb, and I know he's done a lot of research into multiple choice. It might be useful to have some guidelines which can be shared of what makes for good and bad multiple choice questions. Thanks.
Yeah, Derek, I know very well what you're talking about, and I agree. The problem is, I think I've half addressed that problem you've just raised now, but I think that it's very difficult to, all I can do is I can say, if you're going to set a multiple choice exam or anything else like that, then here are some guidelines. But I've tried it, and quite often people almost take the attitude, well, don't tell me what to do, because I think I'm happy doing what I'm doing. And for example, I think it's dreadful to have in a multiple choice exam to have a yes or no answer.
Agreed.
And that's quite common. But I've given talk on multiple choice marking and everything else before at 2 or 3 other conferences and things. And sometimes there's been a spin-off and people have gone into it and they've done what I've suggested. And other times they've just stuck with it, and I still see multiple choice questions with yes or no answers. And that to me is unacceptable.
If I can just follow up, to be honest, as a teacher, I hadn't thought about these things. And it was only really when I did my postgraduate studies that I thought about these things properly. But, if we're academics who believe in peer review, then, people should be open to this sort of constructive input. And I think we must just, keep pushing for people to accept this, particularly when it's a nationwide quiz, and it really makes a difference to the outcome.
Yes, it does, and I agree with you. And I think the SAIP, in fact, is kind of addressing that problem with our teacher program, because we use Professor David Wolf and I, when we teach these teachers as part of the program, we use multiple choice questions. So we can share that information with teachers whilst we're teaching them. So hopefully when they use multiple choice questions, that's what they'll do. They won't have yes or no answers, hopefully.
Thank you.
Aswandini, you have a follow-up question?
Yes, following up on Dirk Fish's question, it's about whether case you have done a study on correlations. I saw publication by SAIP where when they look at probably 3 of the winners from the physics Olympiad, they went on to become the top achievers in the country. And therefore that indicates that it was not a pure guess in the physics Olympiad. Is there some sort of study around that?
No, not as yet, Aswandini. It's early days, because you can really only start doing that once you get proper online processes going. But we will be looking into that, obviously, and I think so far we haven't had that problem.
Thank you. Bonix, you've got a question?
Yes, a simple one. We know that multiple choice questions are not very good at assessing all the qualities. What other methods do we want to use for us to unravel some of the qualities the students have? Thank you.
Well, I think doing the multiple choice question, like what we're doing to identify a few students from a large number, I think is a good filter. It is not the answer. The answer is what I did in 2005 when I was given a big chunk of money, was to, I had 3 rounds. So we had the Olympiad, the SASTRA Olympiad, we then had our Olympiad, and from the results from SAFA, the Physics Olympiad, I took the top 10 and I put them in a residence in Cape Town, and I taught them for a week intensely. They went up to UCT for practicals. They were taught that, they were given extra maths, they were given tutorial problems, and that's the way it should be. In other words, we should identify the talent by this method and then take them into a camp for a specific time or a couple of camps to really get them up to speed, to bring them up to a standard whereby you could say, well, this is now where we, at international level. But that means a camp, and it needs money, and that's something that we're very short of.
Thank you.
Yeah.
Thank you, Bonix. There's a follow-up question about the writing of the exam. When students write online, do they do that from home, or is even the online exam done at school premises?
It's in the past, it's been done at school, with an invigilator there, monitoring what they're doing. But obviously, with the COVID problem, there will be a lot of at home. But I haven't as yet had an Olympiad under these conditions, so I can't really answer that at this stage. But if I'd rather they went to school and did it there under proper protocol conditions and everything else. But I really don't like the idea of them not being as a group together and being invigilated.
Yes, I think that is also the concern with regard to cheating, because I know students are creative and they sometimes have WhatsApp groups, and so student 1 looks at MCQ 1, student 2 looks at MCQ 2, and then they basically have longer time to spend per question because their mates are doing the other questions and they share answers on WhatsApp. And so you do need to have a form of invigilation, I think, to help with that sort of behavior.
Yeah, but even if they use WhatsApp and communicate that way, it's amazing how quickly you use time and you haven't got a lot. So yeah, it is a problem.
Understood. Okay, I see no more hands. Are there any more questions? Let me just check the chat. No. Right. Okay, that looks like all the questions. So it just remains for me to thank Kees very much for his presentation. It's certainly very interesting. There's lots of hard work behind the scenes, and it's I've certainly enjoyed having a glimpse into what goes into running an Olympiad, and I think it's very important for the physics discipline going forward. So thank you very much for your presentation, Kees. Also, thank you very much to Brian Masara and the SAIP office, who, as always, have done an excellent job in the behind the scenes setting up of the Zoom session. And thank you very much to all the attendees who've made the time to attend. And thank you very much for the engagement and the questions. It is much appreciated. So
thank you very much, Rudolph. And I just like to say thanks in a huge amount to Brian, but also Ndanganeni and Tobogo for the hard work that they do. It's much appreciated. I couldn't do it without them. But thank you very much to everyone and to you, Rudolph. We look forward to the future. Thank you very much.
Exactly. Thank you very much. Have a good afternoon.
Thank you.